Welcome to our class today, and I want us to be able to have a discussion on the Spearman's rank correlation coefficient in a situation whereby the ranks have not been given. Remember the other video that we did, the previous video that I did, it was actually having an information where the ranks have already been given, whereby the data that you have been given has already been ranked. This kind of particular data that you see here, that kind of information is whereby the data itself has not actually been ranked. In that, how do I know? So they are saying that the following are the marks awarded by two judges. So this was supposed to be two judges, by two judges there, X and Y, to 8 competitors in a music festival. So it was just marks that was awarded, but they have not told us that they ranked those kind of particular contestants. So again, the other way that you can be able to know that the data that you have been given has not been ranked is that we are going to use some huge figures like 52, 68. You can compare it to the other video. It was having 8, 9, maybe 10, at most up to 12. So, but when you see that we have that 530, then that data has not actually been ranked. So you have to rank it before you prepare the Spearman's rank correlation coefficient. So the question was asking us to be able to calculate the Spearman's. So we should be able to calculate the Spearman's. The Spearman's rank correlation coefficient. So we are trying to calculate that kind of particular Spearman's rank correlation coefficient from the data. So the formula does not change. So whether the data has been ranked or not, the formula is going to be the same formula. But now in this kind of particular situation, we have to rank it first. The formula will remain to be, remember, the rank is always being represented by this capital R, and it's going to be 1 minus 6 summation d squared over n cubed minus n. And so others here, I know that you know that it's actually n squared into n minus 1. It's actually the same. So if you take n squared into n minus 1 under this denominator, then of course if you open this bracket, it's going to be n cubed minus n, so it's going to be the same. So it will be the same there, whether you use n squared into bracket n minus 1 or n cubed minus n, and then of course the answer that you are going to arrive at will be the same kind of particular answer. So information like this, what we are going to do, we are going to have, we'll be able to have our values here. So I'm going to have the x, and then of course I have the rank x. So I'm going to have the value of x, and then of course, because the data, though the data under x here, the whole of it, it was not ranked. So now what we are going to be able to do, we will be able to have rank x. So I'm going to have rank x so that we rank it. So first of all, let me include this data. So the data here is 52, 53, and then of course 42, 60, 45, 41, and then 46, and then that 8. So that's the data. So that's x. Just put it in a vertical format, that manner, and then we are going to rank it. We are going to have the rank of this particular rank x, meaning that ranking is just from the one that is the highest, the one that is going to have the highest value to the lowest, in the sense that you can be able to check this kind of particular data. The highest here is actually 60. So because highest is 60, we rank it as number 1. So we're going to give it number 1 because it's the highest. This is just to be ranking the way we used to be ranked back in the days in primary school and also in high school. So whereby you have several marks, then you become number one. So it's going to be number one there. And then you can be able to see followed by 53, which will be even rank 2. So we are going to rank it as number 2. Followed by, if you can be able to see, is 52. 52 will give it rank 3. And then followed by 46, we give it rank 4. And then you can be able to see that it's going to be followed by 45. We give it rank 5. And then followed by 42, we give it rank 6 there. And then, of course, followed by 38, I mean 41, we give it rank 7. And then lastly, 38, we give it rank 8. So that's how we rank them, from the highest, the one that has the highest now value to the lowest. We rank it first because the data has not been ranked. So you can be able to see now, the answer that we were obtaining here is the same as the previous video, because now that was direct. The data had already been given the ranks. So this one has not been given the ranks, and that's what we have actually done by assigning the ranks ourselves. So we have ranked X. And then now you go to Y. So now that is the Y. So the Y, you can be able to see that the first value is 65. So it's going to be that 65. And then the second value is actually 68 here. And then 43. And then 38. And then 77. 48. 35. And then that. So again, what we are going to add, we are going to rank it, so we are going to call it rank Y. So we'll be able to call it rank Y there. So that's how we are going to be able to call it the rank Y in that kind of particular manner. So that's how what we'll be able to do. So we are going to be able to rank it again. We are going to assign those kind of particular ranks by ranking it again there. So we want to rank Y, and we are going to be able to start from again the one that has the highest number of marks in this kind of particular case. So if you can be able to see, the one that has the highest is 77 is actually the highest, so you give it 1, and then followed by 68, you give it 2, and then followed by, we have 65, you give it 3, and then if you can be able to see the other one that is going to have the highest is 48, you give it 4, and then we are going to have 43, you give it 5, and then 38, you give it 6, 5, you give it 7, and then 30, you give it 8. So again, we have actually done, we have ranked that Y. So we have ranked Y. The next thing that we will now be able to do, the next thing that we are going to do, remember our formula here, which is 1 minus 6 summation d squared, meaning that we must be able to obtain this d squared, which is actually the difference between the ranks. So we are now going to have our d, and then we will be able to have our d squared. So that's what you will be able to add in that table, the d and the d squared there. So what we will be able to do is to find the difference between the ranks as usual, just like the other one now. So now it's going to be 3 minus 3, which will give you 0. 2 minus 2, which will give you 0 there. And then 6 minus 5, which will give you 1. And then 1 minus 6, which will give you negative. So this is going to be 1 minus 6 is going to actually be negative 5. And then, of course, we have 5 minus 1, which will be 4. 7 minus 4, which will be 3. 7, which will be negative 3. 8 minus 8, which will be 0. So that's what we are going to be able to do there. And then of course we get the d squared, and the d squared is going to be this 0 squared, which will be 0, 0. So this is 0 squared, it will be 0, 0 squared, 0 there. 1 squared will be 1. Negative 5 squared there will be 25. And then 4 squared will be 16. 3 squared will be 9. And negative 3 squared will also be 9 there. So what we do now, we are going to add. So we'll be able to sum up. We are going to sum up our kind of particular d, summation d. And if I can be able to sum it up, I'm getting, if I sum it up there, I'm getting 60. So that's what I'm having here. So I'm going to have 60, 60, which is going to be the summation d squared. So when you have now that summation d squared, of course now what we do is to be able to apply the formula. Here. And the formula is going to be now as follows. The formula is this one. So of course let me again repeat it here. So it's going to be rank is equals to 1 minus 6 summation d squared divided by n cubed minus n. So I know others, you know the formula here. Below here is n maybe squared into maybe n minus 1. It's actually the same thing. If you open that bracket, you are going to have n cubed minus n. So in that sense, now if we apply this, our formula here, then now this is what we are going to get. So our r is going to be our 1 minus 6 times summation d squared, which is 60, divided by n cubed. And the n you can be able to see, there were actually 8 competitors. You can count them 1, 2, 3, 4, 5, 6, 7, 8, which is now 8 cubed minus 8. So which is basically we are going to be 1 minus 6 times 60 is going to be 360. And then of course we are going to take 8 cubed, and our 8 cubed is going to be 512. 512 minus 8, minus that kind of particular 8 there. So which is basically 1 minus, so it's going to be 1 minus, let me adjust that camera so that you can see it. So which is basically 1 minus 360 over 512 minus 8, that's 544. Then this 360, so it's going to be 1 minus, so 360 divided by 544 is going to be up to 4 decimal places, is going to be 0.7143. So 0.7143. So if we take 1, we minus that answer, our rank is going to be, so our R, which is the rank, is going to be 0.2857. So that's how we get the rank in a situation whereby the data that we have has not actually been ranked. So in that kind of particular situation, that's what we apply. The formula is going to be the same, in that now you see that the other one was just direct. The other one, I remember it was actually direct, so it was more direct in terms of the calculating. So like now under this one, what you can be able to see, we must be able to introduce that kind of particular rank X, and then of course we must again be able to introduce rank Y. So the other one was just the ranks were directly given, so that's why we were not having those kind of particular rank X and Y. But in a situation whereby the data has not been ranked, Then of course you have to do the necessary by introducing the rank X and also the rank Y, and then you find the difference between the ranks, and then of course you use your formula, and then that will be the end of it. So that's how you deal with such kind of particular question. So again, we are going to have more videos on the same, and keep tuned for new coming videos. So thank you for today.